Can you see my screen? Yeah. All right. So next thing is the matrix representation. Of differential. Of a smooth map. Right? So last time what do we do? We saw how the basis changes, right? Now we have a map from, let's say, M to N, and the corresponding differential F star maps from TP, F star P maps from TPM to TP, FPN. And now we want to represent that map as T varies in a coordinate chart, P varies in a coordinate chart in terms of a matrix, right? Okay, so let's do that. Proposition given a smooth map F from M to N and P is a name and coordinate charts in the coordinate and U x1 x2 xn V y1 y2 yn. Well, here you don't need m n, so ym and coordinate systems at about P and FP respectively. Then the differential F star P TPM TFVN can be represented as presented by the matrix del F I J. Oh no, this is fine. Del F I by del X J at P, where Fi is defined as xi, not xi. Xi is the coordinate system in the domain. So this is yi compose f, and represented this by the matrix this with respect to the basis del by del xi at p I from 1 to n, and del by del yi I from 1 to m, right? So this is at fp. Yeah, so matrix representation. So to get a matrix representation, you need to specify a basis the both side. So we have specified. So what would be the order of the matrix? So this is m by n, right? M by n. Just as in case of Rn, we have the same thing. All right. The question is, how do we prove? Right? And this is not the point, just not for just the point P. It actually gives a proof for every point in the yeah, in the neighborhood, U, which lies in neighborhood P, one have the same thing. The if image lies in V, so these are coordinate system, right? So whatever part of U that goes into V, you have the same thing. All right, we have the same matrix, the same type of matrix representation. All right. So what do we want to? How do we get such matrix proof? So we apply f star p. F star p maps TPM to TFPN. So apply on del by del xj at p. It will be on TFPN. Now this can be written as, since del by del yi is a basis, this can be written as summation a j k at the point p del by del yk at p, right? Yeah, because this forms a basis, right? So maybe I should write that basis for TPM, and this one basis for TFPM. Sorry, N. N. Fine. Now once we have this, and there we are doing proof. Once we have this, we'll do the same thing. You apply on yk or yj, whatever. So we apply that formula on, let's say, yi. So just call this one. So apply both sides of 1 on y I. All right. So apply on y, then what happens? That what happens is the following: f star p del by del xj at p applying on y I. This gives you summation k from 1 to m a j k p del by del yk at this is of course depends on p, but it actually function of fp. So at fp. So since we composition is smooth, so we can take this as p. Is this clear? This part. So this part, why do we write at p, right? So this is a tangent vector in f of p. So this should also depending on f of p. This ideally be ajk at f of p, but this is a constant. You can always write it depending on p, so you can always write it as ajkp. All right, this should be understood in this way. So this is delta ik, right? So summation k from 1 to m ajk p delta ik p, which is nothing but aij at p. All right. Now what is it? Let's calculate right hand side. So this is del by del xj at p yi compose f. So this implies this one is fi by definition, right? So fi is this one. All right. So this is del f I by del xj at p. All right. Therefore, the matrix representation is del fi by del xj at p jij. This is min. Right? Makes sense? Any question here? So, like in case of in calculus, we get these things, right? In the coordinates of manifold. We had to do some hard work to get the coordinate system and to get the coordinates properly. But once we are fine with that, we have the analogous formula. All right. Okay. So this is very important. This so one can do calculations like in Rn in case of here also. All right. All right. So next we look at the curves. So curves in a manifold. So what is a curve? So we'll always look at smooth curves. A map gamma from A to B to N is called a smooth curve So a smooth map. This is called a smooth curve. All right. Now once we have a curve, so what is it? So what is the tangent space of an interval AB? What is the tangent space of an interval AB? Yeah, Devanjit, can you tell me what is the tangent space of the tangent space of the interval AB?
It is R, a real line.
Yeah, what is the basis?
Gamma dash T at T any point in AB.
No, basis of the interval, basis of the tangent space of the interval AB. Yeah, anybody? So what is it? What is the basis for the tangent space of the interval AB? That's it.
Sir, we need to fix a point,
Yeah.
and on that point should look at all the derivations. So all
So,
the derivations are
so
here.
how many linearly independent derivations will be there?
Sir, because it's AB, it should be only one, right?
There should be one. Why?
Because we can look at it as like R, so there's only one direction.
Yeah. Only one direction.
So we know in Rn, the basis will be n. So here it should be 1.
Fine. So what is it? Yeah, that makes
Dou
sense.
by dou x.
Right. So if you consider the coordinate as t, then d by dt. Right. You always do dy dt or dy dx. Right. So this tangent space. So p, you take that p belongs to the interval AB. Then TP AB, the interval AB. Okay, is span over R d by dt at P. All right. There should be no confusion in that. So this is the tangent space of an interval, which is isomorphic to, of course, R. Right. You multiply constant coming from R, that gives you isomorphism. Of course, there is nothing in it. Now, what is gamma star? So gamma star P, right? So what is gamma star P? Gamma star P is a map from TP interval AB to T gamma P N, right? Or maybe I should instead of P we would just put T naught. Call it T naught. T naught. So P we generally consider the point in a manifold, so we consider T naught, T naught, and this is T naught, and this is gamma t naught, right? So, so now what is this, right? So what do you think this will be? Hmm? Well, this depends on gamma prime. I mean, this depends on the component of gamma. So this will actually be a tangent vector here. We'll precisely say what it is, but before that, and yeah, so let us define this different quantity. Let us define this to be gamma prime t naught. Okay, this is a vector, and define this to be gamma prime d naught t naught, which also, I mean, one can think of d gamma by dt. Right. Now the point is, so you have seen that calculus derivative, right? Right. So instead of, and this is called the velocity vector. Vector. Gamma t naught. So yeah, you have seen this in physics. So a particle is moving along a curve, and then you want to consider the velocity. So this is how the expression should be, right? And then of course you know the expression for this one in terms of acting on some function, and then you'll get the expression in local coordinates of m as possible. So I would request you to, I mean, find it. So take m to be Rn and calculate what it is. You will get the known thing. So we give an exercise also. Yeah, maybe let's just calculate. So when m is Rn, then what happens? Right? So gamma is a map from an interval AB to, so this is T naught. T naught, yes. So gamma is a map from interval AB to Rn, and gamma prime T naught belongs to here, is equal to gamma star T naught d by dt at T naught. Now we want to find the expression, right?
Sir,
Yes.
sir, for us another class has started.
Oh, it's already 12. Okay. Yeah. Okay then. So yeah, I got a little late. So okay, so we'll see you next time because it will take some time. In any case, so you just calculate what it is for. Uh, so this one. So at this point, let me put at next time I'll do it, but I'll just urge you to do it as an exercise. Next time we'll also explain it. All right. So yeah, even first you think of this as Rn to be 1 in R you will find that this is the same as the derivative times ddt. So derivative, this will be actually the derivative, yeah, in the real sense.